We'll just start the session. So I welcome you all for the uh, final interactive session, week 12 interactive session of the course Polymers, Concepts, Properties, Uses and Sustainability. Okay, let me just share my screen. So are you able to see my screen?
Yes, ma'am. It's
Yeah,
visible.
yeah, okay. I once again welcome you all for the week 12 live session. So once again, let me see if I started recording. Yes, it started recording. So, as usual, we'll go through a brief recap of week 12 lectures. Okay. So, the major, focus of the week 12 lectures were on polymers and environment. Okay. So, this week lecture, it had four lectures. And the first lecture of the week, lecture 84, was on microplastics, aerosols, and sediments. And this was on the focus of sustainability of polymers. Okay, where the fate and transport of polymers was discussed for polymers in environment. Now, how it is released in environment, the different sizes like microplastic, nanoplastics, and what are their origins, whether it is a primary origin or secondary origins, which of the plastics are having primary and secondary source of origin were discussed. And then the impact of microplastics was discussed in detail. First of all, what are the microplastics, what is their size range, right? And then impact of microplastics and how do they interact with the surroundings, right? In fact, their presence in ocean bed and ocean surface was also discussed, right? And their prevalence in different environment was also discussed, like your water, air, right? And even you could find these microplastics present in the digestive system of vertebrates and invertebrates. So to that extent, these microplastics are having an impact on the environment, right?
Yes, ma'am.
Yeah. And then lecture 85 was on biodegradation of polymers. So this was again on sustainability. Okay, so the degradation of polymers in environment. So what are the different degradation type of degradation polymer will go through, like when it is exposed to atmospheric condition or light, for example, UV exposure will lead to a chain scission, right? And then how does it undergo a thermal and mechanical degradation, and biodegradation and sedimentation and transformation, right? It was all discussed. And the biodegradation process was discussed in very detail, the factors involved in biodegradation. And then what are the conditions, like your pH, right? Salinity, everything, conditions involved, temperature involved in biodegradation, how does it affect? And then structure and properties of polymers, how does it affect? For example, the porosity of the polymer, the diffusivity of the polymer, right? The macromolecular structure of the polymer itself, its molecular weight, how each of these aspects play a role in biodegradation of the polymer were all discussed. And then what are the biodegradable polymers, like biological polymers of biological origin itself, like plant based or animal based. And then bio based polymers were all discussed. And then biodegradable polymers and polymeric waste management was also discussed in this lecture. And then lecture 86 was on biodegradable polymers, you know, and it was again on sustainability. So, what are the polymers with biological relevance? And then what are the degradation claims and all, and what is composting? And what is the biodegradation of different biopolymers like your polyhydroxybutyrate, and then what is the biodegradation and factors is affecting it in case of polylactic acid, and what happens in case of starch-based polymeric systems were all discussed. And the final lecture was again on biodegradable polymers. This was on uses, right? And what are the application and processing, right? Because you have the similar processing techniques, uh, for the biodegradable polymers also, like extrusion and all, right? And also, how can we change from a chemical and mechanical recycling to a more sustainable approach of organic and bio recycling and all was discussed. And what are the most promising application of different biopolymers like your starch, and what are the key challenges involved, and where it is uh, you know uh, used, in which are the applications they are used, and all were discussed, right? Do you remember any application of starch that was discussed?
Yes, ma'am. The shopping bags, the carry bags.
Yes, shopping bags. In fact, disposable utensils, right? And even, for medical applications like your bone cement, right? And even for drug
Yes,
release and all, right? These were the applications. And similarly, polyhydroxybutyrate and polyhydroxyalkanoates, the key challenges involved in these systems, right? And their application was discussed, right? Do you remember anything of these polyhydroxybutyrates? Any application you remember, or in which it can possibly be used in future?
in food packaging.
Yeah, food packaging, and also oxygen barrier, right? As a
Yes,
oxygen barrier especially, right? And then polylactic acid, which is widely used as a absorbing polymers in your diapers, right? And again they can be used as thermoform containers also, right? And then there was a discussion on biodegradable polyester. So how the aliphatic and aromatic polyesters, how can they be biodegraded, right? Was all discussed. And then a thought process was put forth on biodegradable thermosets and elastomers, right? So these were all the discussion that was covered in the final week of lecture, that is week 12, right? Okay. Are you there?
yes, ma'am.
Okay. Okay. Okay, then now let's move on to the practice assignment of week 12. So, film embrittlement, plastic part erosion leads to dash source of polymers in environment. There was a discussion on different sources, right? Two major different sources of polymers into environment, right?
Yes, ma'am. Secondary.
Yes, yes, it is secondary source. So secondary source involves your microplastics, nanoplastics, and all, right? Whereas your primary source, involves like from your the bulk polymer waste from your industries and all, right? Uh,
Yes, ma'am.
and it is a primary source where your macroplastics are involved. Of course, that also involves microplastics and nanoplastics as well. But in case of secondary, you will find these microplastics and nanoplastics, and you would not find your macroplastics. Okay. Okay. Now, question number two: reassociation of starch molecules when gelatinous starch is cooled is referred to as, what is this process referred to as? This was again discussed in your lecture. on starch. So absorption of water, take up of water, gelatinization of starch happens. And when this gelatinized starch is cooled down, there will be reassociation of the starch molecules. What is this process referred to as? Are you able to remember? In starch, there was
Um,
discussion on melting, and then followed by absorption of water, melting, and then there was a process that was saying reassociation of the starch molecules or rearrangement. What was that?
retrogradation.
Yes, it is retrogradation. Okay. Yeah. Now, question number 3. Arrange the biodegradation of polyhydroxybutyrate in the increasing order of its duration. So, which of these processes will take shortest time and which will take longest time? Anaerobic biodegradation, marine degradation, bacterial degradation in tap water.
Bacterial degradation in tap water will be very fast, man. And then marine degradation, and then anaerobic degradation.
Is it marine degradation and anaerobic degradation? So, you're
Yes, ma'am.
saying bacterial degradation is it takes the shortest time. Then
Yes, ma'am. Marine
uh,
degradation.
marine degradation takes the next it's faster, and anaerobic degradation takes the longest time. Can you just
Yes.
justify?
Uh, in tap water, the hydrolysis leads to the monomerchant cleavage. In anaerobic, there is no oxygen, so it takes lots time.
In marine degradation, how does it happens fast compared to your anaerobic? You want to have a guess? You have partly answered right. You have partly answered wrong for the order. This was again taken from your lecture only.
Marine degradation will come last.
Okay, you found out. Yes, it's actually the bacterial degradation takes the shortest time. I mean, the bacterial degradation in tap water. So it takes around 40 days. Okay, and anaerobic degradation, it takes few months. Of course, as you said, this takes place without the presence of oxygen. Okay, there are anaerobic microorganisms that helps in this process, that might help in this process. So it takes few months, and finally is your marine degradation, which takes years. Okay,
Okay.
the next question. The first step in aerobic degradation of polylactic acid is dash.
Breakdown of the ester linkage.
Yes, you are right. It's actually your hydrolysis, which is nothing but a breakdown of ester bonds. So your COO, the ester bonds breaks to COOH and OH groups. Okay, presence of water. Okay, next one. One of the key challenges in application of polylactic acid is there were challenges that was discussed for each of these you know biodegradable polymers, right? Especially
Yes,
when there
ma'am.
was, yes.
The control of morphology,
So the morphology.
like glacier semicrystalline, it's very difficult to control.
Why is it so
The
difficult to
steam,
control? What aspect of the polylactic acid leads to that, whether it is glassy or whether it is semicrystalline?
the LND enantiomers, that
Yes.
makes it difficult.
Yes, yes. It is controlling your stereochemistry. So your enantiomers, as you said, L and D enantiomers, that causes difficulty in application of polylactic acid. Basically, in processing, what happens is that, especially when you have your you know uh, d-enantiomer of your polylactic acid, there is a high degree of crystallinity. Okay, and this crystallinity aspect, it or this controlling the stereochemistry, which may lead to either L or D, that also has an impact on its degradation capability. Like your D polylactic acid, it biodegrades comparatively slower, because as you know that when there are crystalline regions, that alignment has to be broken, right? So obviously your biodegradation capability will be slower in case of your deep polylactic acid. Okay.
Yes, ma'am. There will be no free volume in the crystalline.
Yeah, as the crystallinity increases, obviously there is an alignment, right? There is some kind of an
Yes.
alignment, so that causes difficulty in breaking that alignment, and causing the material to degrade or biodegrade, or whatever is the case. Okay. Now let's go to next question. Petroleum based polymers are all non biodegradable. Is it true
It's
or false?
false. No.
Okay. Why do you say false? Can you give some
Uh,
example?
Polyvinyl alcohol is extracted from petroleum source, no.
Okay.
But it can be biodegradable
Okay.
since it has hydroxy group.
So yes, as you said, it is false. So there was a discussion on biodegradable polyesters also, right? So
Yes, no.
yeah, these are also from petroleum sources, like your polybutylene succinate and all. Okay, so obviously, so though they are from petroleum sources, they are also biodegradable. It doesn't mean that all petroleum based polymers are not biodegradable. So there may, so your polyethylene, other things might not degrade, be by microorganisms or through biodegradation. There may be difficulty, but there are polymers that can be biodegraded even though they are from polymeric origin. Okay. Yeah. Now next question. Biodegradation of block copolymers are faster than random copolymers. Identify if the statement is true or false.
It's false, no.
Okay. Then you're saying that random copolymers can be biodegraded much faster than your block copolymers. Can you just justify why?
Yes, well, in a random copolymer, the diffusions happens very fast, no. But in block polymer, if want to like diffuse the whole molecule and like that,
Is it on the diffusion part?
the the ester linkage will be randomly in the random copolymer. So, but in block copolymer, this is not there. So it
So
makes
you
that
will have
difficult.
blocks of groups. It is not like in random copolymers. You know, both the polymers are randomly placed. Whereas in case of block polymers, no, there are particular blocks of A and, for example, A and B. So, and that will have certain chain length and everything, right? Certain number of chains each block will have, right? So, this leads to difficulty in breaking. Whereas in case of random copolymers, the polymer which doesn't get degraded also, which gets degraded and which doesn't get degraded, for example, are randomly placed. So it is easier to break these things since they are randomly oriented, and it is easier to form smaller fragments. Whereas in block, that block restricts the degradation process. Okay, that is what biodegradation of random copolymers are faster than your block copolymers. Okay. Next question. Polyhydroxybutyrate is brittle in nature. Identify the key challenge in application of PHB based on the discussion in lecture 87. And also try to relate it to the brittle nature based on your knowledge of stress strain curves, which were discussed in your earlier lectures. There was a discussion on stress strain curves, right? When there was a discussion on mechanical properties, right? I think it was in your week 5 or 4.
Yes, ma'am.
So try to first of all identify what was one of the key challenges that was discussed for PHB, and then try to correlate that with the brittle nature.
It's its cost of production is very high.
Its cost of production is okay. That was also one of the key challenge. You say why the cost of production is high in polyhydroxybutyrate? What do you think might be the reason for that?
Ma'am, microorganism uh, produce the rate is very low, ma'am.
Yes, yes, as you said, it's right. So this is from a microorganism. So these microbial fermentation products, the quantity of product you may get will be very less. So your output is less. So obviously, in order to increase your production rate, obviously you have to do a lot of this microbial fermentation. So that will be a costlier aspect. But yeah, so that is one of the key challenge. And in fact, to overcome this challenge, some plant based sources for uh, producing this PHB or any PHA, that is polyhydroxyalkanoates, are also being explored. Okay, that this is an additional information. Okay, but tell me, if does this have any relevance to the brittle nature, or what is the any other challenge that will have a relevance or relation to the brittle nature? Of course, as you said, that is one of the reasons, one of the challenges in PHB, the cost. But there were some more challenges that was discussed.
It's transparency and the toughness.
Yes, yes. So toughness is one of those. So how can you relate it to the brittle nature?
Uh, Toughness as large area under the curve, ma'am. That's as compared to brittle, the stress strain curve.
Yeah, see, in stress strain curve, somewhere you're getting the point. It is you're getting the point of area, but the way of your interpretation is not right. You want to think a little more. What is toughness?
Resistance to crack, like resistance to breakage of material.
Okay. Now, just tell me in relation to your stress strain curves. How do you, estimate the toughness?
Observe of the sudden force, man.
Can you repeat it?
Impact to sudden force.
No. Sudden force application or sudden stress application that comes under your impact, right? Now,
Yes.
what is toughness? These are all different terminology. We tend to mix terminologies like your toughness, your hardness. All are different aspects. They have their own set of definitions. Somewhere you are right. The word area is the clue, which you said.
It has modulus, man.
No, modulus is again a different one. So, okay, let me give you another clue. This area term will come in the definition of toughness.
Can have large strain as compared to brittle material, man. It can withstand large strain.
No. Even a brittle material will have certain amount of toughness. Similarly, a ductile material will have certain amount of toughness. Plastics will have another amount of toughness. So what is it? A brittle, ductile, or a class of material behavior. This toughness is one of the properties. I'm just trying to give clues. You're able to think. If you just remember the stress strain curves of brittle material, ductile material, and all, no,
Stretching of bonds, man.
no, you're going somewhere too much deviated. You want to think for a moment and answer, or shall I give you the answer?
Yield strength, man.
No, no.
Same, man. Itself same.
So you want to think some more time, or shall I explain you the answer?
Oh, you may explain, man.
Yes, okay. I'll explain you the answer. So you know, one is that this is an additional information on PHB. The brittleness of PHB is due to the formation of large crystalline domains in the form of spherulites. Okay, that is the basic reason for brittle nature of polyhydroxybutyrate. Okay, and as you said, the key challenge in application of PHB is toughness. Okay, and how can you relate the toughness and brittle nature is? Toughness is nothing but energy absorption before failure. It is given by area under the stress strain curve. You are able to remember now the area under the stress strain curve, what you did for
Yes.
toughness. Are you able to remember this graph?
Then that only I said first, man.
But your that's what I said. Your word area is right, but even brittle material will occupy. See, it is the area under the stress strain curve, and your brittle material will also have certain area. Your ductile material will have some area under the stress strain curve, and similarly, a flexible rubber-like material. So when you compare brittle, ductile, and flexible materials, your brittle material comparatively, in general case, it will have poor toughness or poor a smaller area under stress strain curve, as you can see in the figure also. This is a general scenario, but of course you can just take it into the understanding of the material. So when you just understand the material, your ductile and flexible material are tough material, whereas your brittle, they are poor, in resistance to crack growth, or the energy absorbed before failure is very less. Okay, and uh, that implies that their toughness is low. Okay. So the brittle polymers, I know as I explained, shows lower toughness. Okay. So it is toughness is nothing but your area under the stress strain curve. It is not that it will occupy less area and all. Toughness is area under stress strain curve. Okay. Uh, Budaya, are you there?
Yes, ma'am.
Yeah. Okay. I think hope you got clarity.
Yes, ma'am.
Yeah. Okay. Now the next question is thermoplastic starch can be obtained by using dash.
Like the source, Anand,
Let me give a
can be
huh?
obtained from corn, potato, wheat,
Corn, potato, wheat
rice.
are all sources of starch, but you get some form of starch in that. So to make it thermoplastic, there will be some addition of some materials or additives. What are those additives?
Plasticizers.
Yes, plasticizers. So plasticizers like sorbitol, glycerol, and citric acid are all used to plasticize starch as plasticize starch. So starch also requires some plasticizer. Okay. Yeah. The next question is growth of microorganism can be used as a measure of biodegradation. Is it true or false? Or let me explain this question in a different fashion. Suppose a polymer is in a polymer you're able to observe some microbial growth. Does this mean that the polymer is getting biodegraded?
You may explain that.
You're not able to get any clue, is it?
I think it's true only, ma'am.
True only you're feeling.
Yes,
Okay.
ma'am.
Okay. The actual answer is false. It cannot mean that a growth of microorganism, on a particular polymer means it is a, it doesn't mean that it is getting biodegraded. Okay. See, the your polymer might or the some kind of additives or some dust or something or whatever is there on the polymer surface may cause the growth of microorganisms, but unless and until it takes up the it as a source of carbon source and it processes it and if you are able to see because of the microbial activity there is some chain scission and breakage, then you can say. But just that some microorganism is growing, it doesn't mean that the material is getting biodegraded. In fact, if you just observe some weight loss or disintegration, or growth of microorganism and all, no, it is not biodegradation exactly. Okay. There should be this biodegradation process, it involves series of stages. Okay. Uh, so that is what even in your biodegradation claim lecture there was this sentence mentioning that weight loss, molar mass reduction, or mechanical property loss are not measures of biodegradation and it cannot be accepted as biodegradation. Okay. There might be some kind of other degradation happening in the material due to some different reasons, like because of your thermal aspects or sometimes your oxidation or something. Okay. But these are not accepted as biodegradation. Okay. Okay. Now let's go on to question number, sorry, sorry. Yeah. Next question is a promising factor for biodegradation is rate of biodegradation greater than rate of accumulation.
True, ma'am.
Is true. Okay, yes, you are right. So if the rate of degradation is greater than rate of accumulation, then the biodegradation process is a promising, sustainable factor or a sustainable aspect. Okay, for this, for the biodegradation. Okay. Now the next question: fragmentation of macromolecules is the first step for utilization as carbon source by microorganism. Is it true or false?
Yes, ma'am, true, ma'am.
Okay. Why is it the fragmentation required?
The fragmentation makes the macromolecule into microplastic. So the the molecule is uh, getting smaller particles, so it's easier to uh, degrade and get it as a carbon source.
Yes. So as you said, it is true. See, because the reason is that very large macromolecules, as you know, the name itself suggests that they are macromolecules. So it cannot be directly used as a food source by microorganism or any biological species for that matter. So first, the fragmentation should happen. So before it can be utilized as a carbon source, and a further process of biodegradation can take place. So this happens basically by chain cleavage, and this chain cleavage is an important step in the biodegradation process, and especially the chain cleavage should be enzymatic to say it as a biodegradation. Okay. Because chain cleavage can also happen through hydrolysis or oxidation or some other means or combination of steps, but enzymatic action, it helps in producing some byproducts of these microbial cycles and all. So that step is also very critical. Okay. Yeah. Now let's go on to the next question. Toxic intermediates are acceptable in biodegradation. Is it true or false?
False, ma'am.
Okay, why do you say false?
The intermediate spots will take part in the environment. Then how can we say it as a biodegradable?
You are right. So toxic intermediates, they are not acceptable in biodegradation. Okay. So because if the, as you said, if the intermediates are going to be toxic, then it is also going to affect the environment. So ecotoxicity, assessment, it is a very critical factor, involved in biodegradation process. Okay. And in general, a biodegradation process can have this biomass and humus and all as which are non-toxic as their intermediate products. Okay. So the toxicity also plays a role. Bioassimilation and mineralization is a final step in biodegradation process. Is it true or false?
True, ma'am.
Yes, true. So these, bioassimilation. So these becomes, metabolic energy source. Uh, the final stage, it is taken up as a metabolic energy source for further, development of the organism, and also of course the solid product that is left, they might be mostly the minerals, and it's nothing but your mineralization. So these are the final steps in the biological degradation process, and of course you will have CO2 and water, right? Because carbon is there, your hydrogen is there, so obviously you will end up with the CO2 and water also produced. Okay. Next question: macroplastics have higher surface to volume ratio than microplastics. Is it true or false?
It's false, ma'am. Only microplastic will have high surface to volume ratio.
Yes. Yes. In general itself, as the size decreases, your surface to volume ratio will increase. And that is, in fact, the basic idea of your nanotechnology and nanomaterials. So obviously your microplastics will have higher surface to volume ratio than your macroplastics. So for example, for a 5 sheet, the surface to volume ratio is 440 meter square per meter cube. This was one of the data that was given in your lecture. Whereas this, the same material, when it is as a 50 micrometer particle, the surface to volume ratio becomes 10 power 5 meter square per meter cube. So it is like orders of magnitude, increase. It is three orders of magnitude. You could see that, right? From 440 to 10 power 5. So it is like three orders of magnitude increase. And this plays a very crucial role in the interaction of your material with the environment. Say for example, if it is in a water source, or if it is in air or in soil. So since the surface to volume ratio is high, there will be much more interaction and much more impact in the environment. And thus the microplastics will have much more impact than your macroplastics, right? Hello.
Yes, ma'am.
Yeah.
Yes, ma'am.
Sorry. Next question. Microplastics are also prevalent in atmosphere as aerosols. Is it true or false?
True, ma'am.
True. Yes, they are also present in as in atmosphere as aerosols. And similarly, in fact, in your biological systems also, you can find in your digestive systems, you can find invertebrates and invertebrates. There are cases where these microplastics have been identified. In fact, you could see these cows and all eating uh, polymers, right? Your polymer covers and all from your waste bins. So it is very essential that you don't throw it as such. The these waste are to be disposed of separately, right? You could have seen near your homes and all, where there are these wide bins on roads, or even if you had thrown some papers or you know plastics, the especially your milk covers and all, you could see that cow is going and eating those things also, which is very unsafe, right? And that is why the sustainability and biodegradation or degradation of plastics uh, becomes very critical, right? Because again it can affect the system, right?
Yes, ma'am.
Yes. So we have to be very careful and conscious in disposing the waste. Okay. So I think that's it with the today's session. So if you have any other queries, we can discuss. And for the benefit of others, uh, I'm just repeating your question on your thermal conductivity. I think you asked in week 10, right? When we were discussing the practice assignments and all, and on the thermal conductivity of polymers and all, you asked a question on does stretching of polymers leads to increase in thermal conductivity. So, yes, it helps in aiding or improving the thermal conductivity of the material because the alignment is improved. The polymer aligns, upon stretching. So, there will be an increase in thermal conductivity. Okay. Uh, do you have any other questions, Udaya?
No, ma'am.
Okay. Uh, so, you don't have any other questions. Okay. So, were you able to solve all your previous assignments?
Yes, ma'am.
Okay. So you don't have any other doubt in any other lecture. So you're clear with all the concepts and all, right?
Yes, ma'am.
Okay. Okay then. So that's it for the session. So in case you have any further doubts, I'm not sure if we will be having another session, or we might have, before your exam, a week before your exam, or 2 3 days before your exam, some kind of a review session. I'm really not sure of that. But don't wait for that if it is really going to happen or not. Try to post your queries if you have any other queries when you're going through, the lectures. If you have further queries, please post it in the forum. Okay. And we'll try to answer it at the earliest possible, so that you're able to get clarified, and in case something related to that is asked in the exam, you are able to answer those also. And again, as I said, your doubt on the heat deflection and your TG that you have posted in the forum, I'll get back to you. I'll just reply through the forum. And someone has asked on the model of question paper, right? Whether it'll be like MCQ alone, or so your question paper will have MCQs, fill in the blanks kind of thing, and also your essay questions. I think you would have received a mail on, there was, I think you would have received there was a mail on, the format of your exam question paper, right? Did you see that?
Yes, ma'am.
Yeah, so it will have, mix of questions. And again, you cannot take your physical calculators and all. So there will be an online calculator, and I think they have given a link for that also, how to use it and get a hold of using that also. Okay. So try to, use it and see if you are able to, work fast with that, so that you don't suffer on the day of the exam. Just try to practice with that. Try to solve problem. Even you can just do the calculations, whatever of the problems that are discussed in the lecture, or that are discussed in the problem solving session, right? With that calculator, so that you get used to that calculator as well. Okay. So I think your exam is going to be computer based online exam, right? And also, there was a question on, a part of graph was not visible, and I've answered that question also in the previous session. I think Shivakumar has asked, right? He was not able to, especially on the linear and exponential, you know mm, difference, when the particles are placed, right? In the last week's lecture, I think you also saw the question. Oh, right? It is like if you place one particle on top and one particle on the bottom. So when you just apply a shear, it will be a linear kind of change. Whereas when it's an extensional flow, the same two particles, you're pulling like this. Whereas in shear, it moves like this. It moves like this. So it will be a linear kind of change, or with the interparticle distance. Whereas if it is an extensional flow, it will be a pull. That is what's explained in that portion. I think that graph was not displayed in the lecture, right? Hope you remember that. Uday, are you there?
Yes, ma'am.
Yeah, I hope you were able to get that point, right? So considering two
Yes, ma'am.
points, one point above and below. So if it is a shear, it will move like this. Since it will move like this. Whereas if it is an extensional flow, it will be a pull. So that is why the interparticular distance, it increases exponentially like this when there is an extensional flow. Okay, hope you got that point, and hope Shivakumar also saw that explanation in the previous lecture, or else at least now I'm showing physically also with my hands, so he could get that point. Okay, uh, so that's it with the session. So for the benefit of all, if you have any doubts, please feel free to post it in the forum, because as I said, we may not have any live interactive session after this, because all your week's lectures are all over. So I'm not sure of possibility of having a review session or not. In case if that is if in case we have those review sessions, make a list of queries also, and first of all try to post it in the forum. Don't wait for the review session. So post it in the forum, so that we'll answer it. In case you miss that, and in case we have a review session, then please, feel free to ask during the review session, so that you are able to get clarified with all your doubts. Okay. Okay, that's it with this week's session. Okay, thank you, and all the best
Thank
for your
you.
exams. Thank you.